Okay, and now we're going to touch on reduction with cofunctions. I did not include it in the other reduction because I knew that people tend to make silly mistakes with this and get very confused when they're walking through this, right? So the ones that you need to know are 90 minus 90 plus 270 minus 270 plus, right? Sine becomes cos, cos becomes sine. Let's give you an example. Let's say I have cos of, right? If I have something like this, you ask yourself, in which quadrant is this? This is 90 minus theta, so it's in the first quadrant. In the first quadrant, what is cos? Cos is positive. So that means my answer for sine is going to stay positive. And that's what you would do. Okay? If I gave you cos 90 degrees plus theta, let's try this one. This here suggests that it's in second quadrant. In second quadrant, cos is negative, and then we change it so it becomes sine, and then whatever the angle is over there, sine theta. We do the same thing for 270 minus and plus, right? Let's say sine 270 degrees minus theta, for example, right? 270 minus theta suggests that it's in third quadrant. In third quadrant, sine is negative. So negative cos theta. And let's try sine of 90 degrees plus theta. Let's try this one. 90 plus gives us second quadrant. In second quadrant, sine is positive. I don't have to write that. And then we just write cos of theta. And that's how you would reduce it. Let's try a few more examples where we have numbers. Okay, here we go. We have a number, and the instruction actually says write each of the following as a trigonometric ratio of 20. Okay, this is an acute angle, and that's why we're not just leaving it as that, because the instruction says write it as a ratio of 20. So when we're doing this, you need to know the complement of it, okay? Because the complement of 70 would be 20. Think complementary angles when we learned Function in grade 8 and 9. This here would be the same thing as cos of 90 degrees minus 20. 90 minus 20 is in quadrant 1, and in quadrant 1 cos is positive, so this here is going to be cos of 20 degrees. Sorry, I wrote cos over here. That's supposed to be sine. Right, let's continue. We have cos of 200 degrees. This here is the same thing as cos of 270 degrees minus 70 degrees. Right, we can do that, which is the same thing as 270 degrees minus 70 degrees is the same thing, is in quadrant 3. In quadrant 3, cos is negative. So this is going to give us negative sine of 70 degrees. But we don't want negative sine of 70 degrees. This thing said we needed it to be something in terms of 20, which we now know sine of 70 degrees is the same thing as cos of 20 degrees. So this here can just be negative cos 20 degrees. Okay, here's a more complicated or complex question. We need to simplify this. The instruction says simplify. So 90 degrees minus x, quadrant 1. In quadrant 1, sine is positive, so cos of x. Right, I'm just going to put it in a bracket. Over here, 90 degrees plus x, quadrant 2. In quadrant 2, sine is positive, so this here is just going to be positive cos x over. Now in trigonometry, you're not only supposed to know all your trig rules and ratios and identities and all of that, you also need to know all of your information about what's this difference of two squares and things like that. So, or factorization and stuff. Can you see this here is difference of two squares? How do I know that? I have the exact same things in the brackets, just one is minus, one is plus. So I'm going to make this sine squared of 90 degrees minus sine squared x. That's what I'm going to do, okay? And then we need to simplify this even further. So what are we going to do? This here at the top gives me cos squared x over sine squared x minus, so sorry, 90 degrees minus sine squared x. Right, if you look at this over here, I have a special angle, right? Let's go back to our special angle page. We are looking for sine of 90. Sine of 90 is y over r, which is, our y value is root 4, our r value is 2. Let's do that. Cos root 4 over 2, and it's all squared, minus sine squared x. That's what we needed to do. Root 4 is the same thing as 2. 2 over 2 is 1. 1 squared gives me 1. So at the top I have cos squared x. In my denominator I have 1 minus sine squared x. This is important because this here touches on our identities. Now identities have the one, let's write it down really quickly for you guys. We have an identity that says 1 is equal to sine squared x plus cos squared x. From here, if I wanted cos squared x is the subject, I could say 1 minus sine squared x equals cos squared x. And the same thing, if I wanted sine squared x as the subject, 1 minus cos squared x equals sine squared x. And you would notice over here I have this one here. So this part here is basically this. So I have cos squared x in the numerator. Denominator also gives me cos squared x. Cancel and cancel. My final answer is 1. And this is how you would work with your cofunctions and reduction formula and all your knowledge of factorization as well as all your identities.